Hi everyone. Today's video topic is selections in Java. Um, Selections or decision statements are implemented in all programming languages. They're one of the fundamental features of each language, and they allow you to control the flow of execution. With selections, we can implement a control flow statement similar to this one that says if something is true, then do something. Otherwise, do something else. Okay, they're based on Boolean expressions, which means that the expressions that you're testing need to evaluate to either true or false. Those are the two Boolean values, and they're going to help you control the flow of execution, as I said. All right, so this one first example here that we have, let's test that in our IDE. I got that already copied into my JGrasp editor. I don't have a separate project for it, but that's fine. JGrasp allows you to execute just individual Java programs. So you just go to File, New, create a new Java program, and then you already know the basics. You need the class, you need the void main function, and then in here is the code that you need executed. So the code that I'm testing is this if-else statement that says, well, right now it says if radius is negative, then display incorrect input. Otherwise, use that radius to calculate the area of a circle and print the result onto the console, formatting it to be a floating point value with 2 digits after the decimal point. So this is a good example. I'm not sure we've seen this before. If you want your doubles and floats to be displayed with a certain precision, with a certain number of digits after the decimal point, this is how you can do it in Java. Use the printf command with modifiers. And actually, that's part of the lecture today. So we're going to get to that a little bit later today. So in English, what does this program do? This if-else statement is attempting to provide some level of error detection and handling. So it's going to check and see if the user provides a value that is negative. We don't want to proceed. We want to display some kind of error message. Otherwise, we proceed and we compute the area. Now, I initialized radius to 10. I haven't initialized area to anything because this is what we're computing down here. Let's test this real quick. I'm going to click the little run button. The program gets compiled and the end result is that I see 314. Now if I change the value of radius to something negative, say negative 10, and I execute that, this time I get incorrect input. I want to jump ahead here and show you real quick how you can use one interesting feature of JGrasp that also exists in other IDEs. But if you want to debug your code, if you want to get inside the execution cycle, you go from statement to statement, you can place these little red dots here on the left side. They're called breakpoints. So I'm going to place one here, and then I'm going to go to Build, Debug, and here you're asking the IDE to run the program for you, but to stop at the breakpoints and let you examine the state of the program. And by state, what I mean is you want to see where you are and where the values of all of your variables are, what the values of your variables are. So I run the program and it stops right here. Now I can step through the code with the help of, if you just want to do a regular step, you can use Alt with the down key. That's what I'm going to use here. Over on the left side, I can see the state of my program. I've got the radius. It has a value of negative 10. Area isn't defined yet, so it's not in here. It's unusable. I'm going to click Alt with the down key. I'm going to go inside the if statement, which means this Boolean expression here evaluated to true, and that's why I'm in here. And so the incorrect input statement should get printed into the console with our next step. Alt down key, there it is. Inside the console I see incorrect input and my program ends. Alright, now I'm going to take out the negative sign here. whoops, and then do one more debugging run. Again, the execution stops at the if. Radius now is equal to 10. I can see that over on the left side. I hit Alt down key. Now this time the execution skipped the if part, or the if clause, because the expression after the if evaluated to false. Okay, radius was in fact greater than 0, so this thing isn't true, and the whole body of the if gets skipped. We're down into the else part, and we start executing the commands that are in here. Alt down. You can see that the area variable now showed up on the left side and what its value is. One more time, I get the area displayed, and one more time to end the execution. So that's how debugging works, and it helps you. Now this is a fairly simple program, and I'm sure you really didn't need to debug it to figure out exactly how this worked. But once you start creating bigger, more complex programs, debugging is going to be quite useful to keep track of where you are and what exactly is going on with the memory of the computer. I'm going to click on that red dot there to get rid of it and delete the breakpoint, and I'm going to go back to my presentation. Oops, there it is. Okay, the Boolean data type is represented by two literals, true and false. And whenever you're dealing with Boolean variables, their values could only be either one or the other. So here we got a lights on variable. We assign the value to true, so we declare it and assign a value. This is what we call inline initialization. We got a Boolean variable called b, which gets the value of, well, it's going to be either true or false depending on the value of radius. The computer is going to compare radius with 0. If radius is greater than 0, then b is going to get the value true. Otherwise, it will get the value of false. And finally, down with the last example here, computer compares radius with 0. If it happens to be less than or equal to 0, then this one command is going to print true. Otherwise, it will print false. The relational operators are the ones that we use whenever we do comparisons in Java and in most other high-level languages. Over on in the first column, we can see the list of relational operators: less than or equal to, greater than or equal to, and not equal to. Now, if you've never done any programming before, the first four are going to immediately make sense to you, but the last two are probably going to seem a bit tricky. Let's take a closer look at them. The comparison operator in Java and in quite a few other high-level languages is the two equal signs. This is so that we can distinguish it from the assignment operator. Okay, so whenever we see this in our code, we are really taking whatever is on the right side and assigning it to the variable on the left side. It's the assignment operator. Whereas this one here, the comparison operator, takes the two operands, the one on the left and the one on the right, and it compares them. If they're equal, the expression, the computer returns true. If they're not equal, you get back the result false. So please make sure you understand this difference. This is one of those common errors for beginner level programmers, mixing these two. Okay, one is the assignment, the other one is the comparison. Oftentimes, all you really need in your code is just a single if statement. You don't have to have an else part. It's completely optional. So over here in this example, we check and compare radius with 0. If it's greater than or equal, if radius is greater than or equal to 0, then we proceed to calculate the area and we print the result. So depending on what problem you're trying to solve, this kind of if statement could very well be the solution. The else clause is completely optional. Do not forget that you need to have your if expression enclosed in a pair of parentheses. Most of the times when you see the comparison operator, you won't forget, you just remember about these, but sometimes what you have here is just a single variable or maybe a method call, and you might be tempted to leave out the parentheses. That will cause a problem. That will cause an error. So please remember that you always need to have a single pair of parentheses that go with the if. As for the curly braces, they define the body of the if, and it's good to have those always there, but it is true that if you only have a single statement following the if, then they're optional. So the system won't complain, and this is perfectly fine. In this example here, we have just a single print line statement. The curly braces are in fact optional in this case. What's wrong with this code? You can immediately tell the parentheses are missing. That will cause a compile time error with most compilers. Down here, we've run into this before. Please assume that this whole thing is printed on a single line. So let me see if I can fix that. It doesn't quite fit in the slide, and that's why it shows up on the next line, but we never want to have a hard carriage return in the middle of a statement. I'm going to reformat that with a smaller size and make it fit on the same line. Otherwise, we should count this as an error as well. Alright, that's better. Okay. A simple if demo. So here is an image. I can't really copy and paste, but you get the idea. What we're doing in this piece of code is we invite the user to enter their age, and then we read an integer from the keyboard. We print out you are, and if it turns out that their age is less than 13, we're going to display too young to create a Facebook account. Otherwise, we stop there. So we will be able to see the UR on the screen, but that's where the program is going to end if the user happens to be of age 13 or older. Okay, the two-way if-else. This is a very common command that you would use on quite a few occasions in your programming this term and in the future if you continue to program. The way it works is you say if something is true, then execute this list of statements, else execute a different set of statements. So that's the syntax that you're seeing here. Quite like with the body of the if, the else requires the curly braces, but if you only have one single statement here, then they become optional. Okay, and a quick example. If radius is greater than or equal to 0, we go ahead and compute the area, and then we print it. Otherwise, we display the error message, you have negative input. Multiple if statements. This is also used often in programming, the so-called if-else if. This is where you look at various cases and you exhaust all the possibilities with the help of an if-else if. How does it work? Now usually this comes in handy if you're dealing with ranges. Okay, you don't really need this. It will work, but you don't need it with discrete values. There's a separate statement for that. It's called a switch statement. We'll see that in a moment. But here we are dealing with ranges, and we are attempting to assign a letter grade based on whatever the number score is. So if score happens to be greater than or equal to 90, then we go ahead and we assign the value of A to the character variable grade, and we're done with the if statement. Otherwise, we check again and we see is score greater than or equal to 80. Now at this point we know that it's less than 90. So if score is in between 80 and 89, we're going to assign the value of B to grade and the if statement. If that isn't true either, then we'll go on to the next else. And we continue like this until we look at all the possible cases. Now at the very end here, if score is, at this point we know the score is less than 60, so there's no need for another if. It won't hurt if you put it in there, but it's really redundant, so we can just say else. We go ahead and we assign F to grade. Okay, and that summarizes what I just said about the way the if-else if works. Feel free to test this at your convenience and make sure you know exactly how it works. Feel free to use the debugging trick I showed you earlier. Now let's see if we can figure out exactly what's going to happen if score is 70. Let's play computer here. When you play computer, you don't have to make sense out of what you're doing. You're just executing the commands line by line. We start up at the top. Is score greater than or equal to 90? Nope, it's currently 70. So we go on down to the else part. Is greater than or equal to 80? That isn't true either. So we go on down to this part. Is score greater than or equal to 70? Okay, now that's true because score is 70. Come in here, we assign the value C, character C, to the variable grade, and we come out of the if. Down at the bottom, we're going to print grade is with the value of grade, which in this case happens to be C. Okay, some of the common errors and pitfalls, they're listed in the textbook as well. I'm going to try and keep these in the presentations because they are indeed common errors, and even if you know about them, you're bound to run into them. So it's kind of nice to get acquainted with them and start getting the hang of how to handle these. First one that we have in the list here is forgetting the curly braces. The resulting problem would be there's no compile time error here. Okay, so the syntax is correct, but as far as the computer is concerned, this if ends with that semicolon right there. Okay, and it's never gonna if the system out print line part actually comes out of the if, again, as far as the computer is concerned, and regardless of what the value of this expression is, the second command will always be executed. So I'm assuming that that's not what they had in mind here, and that's why they say it's wrong. If we wanted both of these to be part of the if, then we would ensure that they're enclosed in curly braces. So the point they're making here is that this is a very common error. Be careful about this. Be wary of this common error and always check on your curly braces. The wrong semicolon, another one really hard to catch because your compiler is not going to complain about this. And I guarantee you're going to make this mistake. Inadvertently putting a semicolon at the end of the if header. Okay, so this is the if header. This is where you specify if something is true, then, well, obviously this semicolon is going to end the if right there. It's going to kill it. But this is not a compile time error because essentially what you're telling the compiler with this piece of code is that if radius is greater than or equal to 0, then don't do anything special. Okay, it's like an empty statement. It's not an error. It just says, okay, do nothing. Down here, that's not an error either. You can use those curly braces to indicate that this is a block of code. Okay, the compiler is not going to complain about that either. So be careful about this. Always check and make sure you haven't killed your if right there where the header is. Okay, it should not be there. So after the if, you open up. That's why I try to always open up the first curly braces on that same line. It's easier to read and it helps you avoid this kind of pitfall. Common error 3, it's the dangling else. This is where it becomes difficult for you to match your else with an if. So if you've got an if within an if, or nested ifs, which is perfectly fine in programming and people use that quite often, it is recommended that you're really careful about the way you indent your ifs and elses so that you can easily tell which one goes with which one. If you're not using any curly braces, like in this case here, your else is going to get matched with its closest if. If that's not what you intended to do, then you got to make sure that you're using curly braces to tell the compiler exactly where which if the else is supposed to go with. Alright, that takes us to logical operators. This is the third type of operators we're seeing. We saw mathematical, we saw relational, now we're looking at logical operators. Here's the list of those. We got the logical not, we got the logical and, the logical or, which is two vertical bars. I don't know if you can On your keyboard, you'll probably be able to find those next to the Enter key, and then the logical exclusive OR, which is your caret. Okay, so let's see how these work exactly. The not is simply going to invert the value of a Boolean variable. Okay, so if your value, if the expression happens to be true, such as in this case here in the example, then the not, the exclamation point that you place in front of it, is simply going to flip its value to false. Okay, so we'll actually use all of these, and you'll see quite a few examples of when this actually turns out to be useful. Right now we're just building our toolbox. We are learning about the syntax of these and what they mean. So the not flips the value. If it's initially true, it makes it false. If it's initially false, it makes it true. The logical AND, the way that it works is it takes two operands, two values, and it results in the value true if and only if both of these values are true. In all other cases, it's going to return false. So again, if you're using the AND operator, which is the two ampersands, the way that it works is it takes the two operands that are on both sides of the operator. If they're both equal to true, the end result is true. Otherwise, it will return false. The logical OR is only going to return false if both of the operands are false. In all other cases, it's going to return true. The exclusive OR, another very interesting and actually quite useful operator, is going to tell you whether the two operands are different or not. So it returns true if the two operands are different, and it returns false otherwise. A quick example of the last three being used here. So we assign the 2014 number, and we print out is number divisible by 2 and 3? Now if both of these turn out to be true, then the end result is going to be true, and that's what will get printed. If one of these turns out to be false, then the overall result will be false as well. Okay, so how do we read this in English? If we divide number by 2 and there's no remainder, so the remainder is 0, then we know it's evenly divisible by 2. Likewise over here, when we divide number by 3 and there's no remainder, so in other words the remainder is 0, we know it's evenly divisible by 3. It's a nice little shortcut that people use to tell whether the number is divisible by some number, in this case 2 and 3. Down on the next line we say is number divisible by 2 or 3? Okay, we're going to carry out the same comparisons, but this time it will suffice for one of these to be true for the end result to be true as well. And then finally the question we ask is number divisible by 2 or 3 but not both? We use the exclusive or operator for that purpose. If this one is true and the second one evaluates to false, the answer will be yes, the end result will be true. Or if this one is false but the second one is true, again the answer would be true. In the other two cases we'll end up with false. So just a quick demonstration of how these logical operators work. Maybe not the best one, a little bit complicated, but still a nice little summary that you can test in your own code to check and see how they work. That takes us to the second big statement that people use whenever they can create decision statements in Java. It's called the switch statement. So we have the syntax for that is switch. We provide some kind of expression or value between parentheses, and then we list all the possible cases. So we say in case the value of this switch expression is whatever value 1 is, I want you to execute statement 1 and then end the switch. However, if the value of my switch expression turns out to be this, then I want you to execute statement 2 and then end the switch. At the very end we have in all other cases, this is optional by the way, we don't have to have it there, but usually it helps. So what this says in English is in all other cases I want you to execute whatever's down here. Okay, the break statements are actually needed in order to end the execution after each one of these cases. It is true, however, that they're optional. So in rare situations, you actually might benefit from combining cases. For example, the way you read this in English is, if my switch expression evaluates to either 1 or 2, to value 1 or value 2, then go ahead and execute statement 2 and then end the switch. Okay, this shows up rarely in code, but it does actually exist, and it's perfectly valid. So just keep in mind how the break works and make sure that you use it appropriately. Okay, and one of the common errors for getting the break in this example here that you see clearly, they do need the break, because what they're doing here is they're saying, based on the value of ch, which is my character variable, I want you to print it. Okay, if ch is a, I want you to print a. If ch is b, I want you to print b. Now this isn't exactly how this is going to work if ch turns out to be a. We don't have any breaks, so what's bound to happen is we're actually going to see all three of these are going to get executed. Nothing's going to break the switch statement, so we'll print the value of ch 3 times. Okay, if ch turns out to be equal to b, then we're going to see it twice on the screen. And the only time when this is seemingly going to work is if ch is equal to c, in which case we're going to print out just one c. This would be the correct way to revise that code. Make sure that the breaks are in there. Of course, there's no need for a break at with the last statement down here. Okay, the ternary operator. Programmers like this one quite a bit. If you find it difficult to understand and difficult to use, you don't have to use it, but please do know that it exists. It's really a shortcut for the if-else statement. Okay, so if we have this statement up here, if x is greater than 0, assign a value of 1 to y, otherwise assign negative 1 to y. The way we can write that on a single line in a shortcut notation, if you will, is this. Okay, it says the exact same thing. So if x is greater than 0, make sure that the value of this entire expression on the right side here is whatever the first item is. So y is going to get the value of 1. Otherwise, if this thing on the left is false, then make sure the value of the entire expression is equal to the second item, which in this case is negative 1. Okay. If you like it, by all means use it. It's not really a whole lot more efficient than the one on top here. It does exactly the same thing that the chunk of code you see up here. Okay, and here's an example of that statement in use, in action. So we're trying to figure out whether n is an even number or odd. We can do that with a single line down here. We divide n by 2, we look at the remainder. If there's no remainder, we assign a word even actually to the entire expression here, and that's what gets printed into the console. Otherwise, we assign the value of odd to this entire expression, and that's what gets printed into the console. Formatting output. We did actually see this in the very first example today. If you want to format your output, for example, you want something to be displayed as an integer or as a floating point value with a couple of decimal digits, then you could use the percent sign to accomplish that. Here are the codes or the specifiers. %b means I want to see a Boolean value there. %c is for characters. %d is not for double. Please note this is for a decimal integer. Most likely this is the one you're going to be using whenever you need some formatting. %f is what we use for floats and doubles to display floating point value. %s is for string. And here's an example. Okay, we got an integer, we got a double, and if we want to stick those inside a larger string, here's the best way to do it in Java. We say printf, and then in between the double quotes we have the actual string, and we have %d where we want the integer to appear, and %f where we want the floating point, the double to appear. And the .2 tells the compiler we want to see 2 digits after the decimal point. Okay, and operator precedence and associativity, we started that last week, talking about the precedence of addition, subtraction, multiplication, and so on. We are returning to it today because we have looked at relational operators and logical operators. Okay, so you already know how precedence works and how you can use your parentheses to enforce a certain type of precedence. We know about associativity. This is probably the new part for you today. This is where we add the logical and relational operators into the mix. I do in our week 1 folder, I believe I placed the precedence table that included all the operators, including these ones. But this is just a smaller summary of the operators we're seeing this week. Okay, level 1 here is actually at the very bottom. These are the least binding. These are the operators that will be executed last. Okay, and then as you go down the list, they become more powerful and more binding. So in this list of operators, the most powerful ones are the equality ones. So if you have no parentheses in your larger expression, then these will be the ones that will be executed first. Then you look at your bitwise AND. Okay, we haven't done these yet. Well, I'll explain these as we get further into the course. We'll probably use these as well. Today the ones we saw are logical AND, logical OR, and then the NOT, and the logical XOR, which actually they work quite like the bitwise ones, with the exception that we're not really concerned about the values of the individual bits. We're concerned about the overall values. Okay, let's put it that way. Associativity, do remember that if you have no parentheses, binary operators are going to get executed left to right. So for example, here we got a subtraction, addition, subtraction. They all have the same precedence. They'll be executed left to right. It's like subtracting B from A, then adding C to that, and then finally subtracting D from it. The assignment operators, however, are right associative. So if you see something like this, and this is actually valid code, valid syntax, provided you have a semicolon at the end, the way that this is going to get executed in your code, the 5 will get assigned to C, and that whole thing will get replaced by a 5. It will be added to B and assigned, the value of B will get updated with it, and then the whole thing will be replaced with the new value of B and assigned to A. A visual demonstration of how this works. If you've got a large expression here, this time into the mix we have one comparison operator, so you can see that that's the last thing that gets evaluated. The minus, the subtraction, the addition, the multiplication, they're all more powerful and more binding, along with the parentheses, of course. So those are the ones that get taken care of first, and then at the very end we do the comparison. Okay. And that pretty much wraps our discussion on selection and decision statements in Java. Thank you very much for watching.